Section 2.3, Frequency Distributions and Related Graphs. What is a frequency distribution? Well, it's just a table. It shows intervals, which we call classes. And along with those, we have the number of data points in each interval. So we have a data set with various different recordings, and we have the frequency. So our first class, we see that 5 of our data points had values as little as 1, but as large as 5. In our second class, we know that there were 8 data points that had values as small as 6, but at most 10. And the reason we do this allows us to see patterns in our data. Now, the sum of our frequencies must equal our sample size. So this F that we're talking about, this Fi, that's our frequency. So F1, frequency for class 1. F2, frequency for class 2. So you got your sample, N, and you've got to take each of those data points and put it into one of those classes. So that is why N, our sample size, must equal the sum of the frequencies. So we want to construct a frequency distribution so that we can see patterns in our data. We'll do this step by step, starting with finding the range. After that, we need to determine the number of classes, so the number of rows in our table. After that, we'll determine our class width, and then choose the lower value for our first class. After finding the lower value for the very first class, we then go and calculate the values for the remaining classes. Only after finding all those lower limits, we then go and determine the upper value, so our upper limits for the classes. And then once we've found the classes, we can then go and record the frequency. So we can go tally, look at the data set and find how many of the data points lie in each class. So let's try an example. We have this table here, gives us weights in kgs of 50 parts made in the factory. So here we've rounded off to the nearest kg, so we're working with just integers. So our first step will be to find the range. So we're going to need to find the minimum and maximum values. So here we'll just have to look around, 88 and 7, so our range is 88 minus 7, 81. Our next step will be to determine the number of classes which we use the letter K. Not C, although you would think it would be C. Just now we use the letter C for something else. So our number of classes is K. So we're going to use something called Sturge's rule, and we'll discuss finding the number of classes other ways later on. But for now, we're going to use this Sturge's rule. And K is the number of... So our next step is to find the lower limit of the very first class. So we've already identified that 7 is the smallest value, so then we're going to let the lower limit of the first class be 6. After this, we're then going to need to find the lower limits of all the rest of the classes. And the way we do that is we add the class width, which is C is 12, to the lower limit of each of the previous classes. So we 6 We add 12, we get 18. We then add another 12 to get 30. We keep going, add 12, we get 44. Add 12, get 54. Add 12, get 66. And last of all, add 12 to get 78. So now we have the lower limits of each of our classes. Next, we need to determine the upper class limits. So these are going to be 1 unit less than the lower limit of the following class. So if we see the second class here ends at or starts at 18, which means that the first class is going to end at 17. The third class starts at 30, so that means the second class is going to end at 29. And you can do this for all the remaining classes. Now notice, to get from lower limit to lower limit, what we did was we added 12. That's our class width. Add 12. Add 12. And we kept going all the way down to the bottom. With the upper limit, it's the same thing. You add 12. Add 12. Add 12. So if you keep going right down to the end, you add 12 to the end and you get your very last upper limit, 89. So there we've got our class limits, and the very last thing to do is just simply go and determine our frequencies for each class. So we're going to go tally. So we just go back to our table and we check each value, which class it goes into. And if we do that, we'll find that in the first class we have 5 values that range from 6 up to 17. Second class, there's 9 values that have a minimum value of 18, it goes up to 29, and so on. And if you sum up those frequencies, it'll come to 50 because we have 50 in our sample. So let's look at selecting classes. Some classes form naturally. So for example, class marks. All those who got marks of 0 to 9%, and all those that got in the teens, so 10 to 19, all that got in 20s, so 20% up to 29%, then in the 30s, 40s, all the way up to those that get into the 90s. This is a special case. In that very last class, you'll have to add in just the value 100. So it's not just in the 90s, it's in 90s, and one extra one to get to the hundreds. Otherwise, we use Sturge's rule, sort of like a rule of thumb. If you have no idea what else to use Sturge's rule. And so it's convenient, which is why we used it in our previous example. There are some rules when selecting class limits. First is the classes shouldn't be too large or too small. This is because you might not see a pattern. Then each data point must be in only one class. So let's suppose, like our previous example, you have 50 recordings in your data set. You can't just choose 48 of them and put them into classes and ignore the other 2. And not only that, let's suppose you have one particular data point. You can't put that into 2 classes. Also, your classes should not lead to ambiguity. So put this together. Let's suppose we've set up these classes: 16 to 19, 18 to 23, 22 to 29, 30 to 35. Now notice straight away you can see the first class and the second class overlap. The second class and the third class also overlap. So where does the number 18 go? So if you have a data point, number 18, notice it's in here, it's between 16 and 19, but also it's in here. Okay, it's equal to 18. So which class does it go into? That class or that class? What about something like 29.3? So this has got a decimal. We haven't looked at these yet. So this goes from as little as 22 up till 29. So 29.3 is bigger than 29, so it can't go in here. So let's look at the next class. This is as little as 30 up to 35. Now 29.3 is smaller than 30, so it can't go in this. So it's floating somewhere between the two. There's nowhere for it to go. So let's look at the difference between class limits and class boundaries. So here we've got our class limits from our example and our class boundaries. So I'll show you where those come from. But notice, in our class limits, the upper limit of one class is 1 unit smaller than the lower limit of the next class. Whereas the boundaries, these are the same. Okay, so we had a problem of, let's suppose we have a value 17.3. In the class limits, well, it's bigger than 17, so it can't be in the first class, but it's less than 18, so it can't be in the second class. We don't know where it is. So if we instead use class boundaries, we get away with this, okay? We sort of fix this. Well, 17.3 is less than 17.5, so it goes into this class. So class limits, there's this gap between the two classes, whereas class boundaries, there's no gap. And the way you actually find these class boundaries, let's look at these two here. What is halfway between 42 and 41? So we want to join up the upper limit of this class and the lower limit of this class. So halfway between them is 41.5. So if we go along, this becomes 41.5 and this becomes 41.5. Okay, so this one goes up by half, this one goes down by half. That's what you'll do with all of them. Now something to note though, class limits, you go up by 12, 12, 12 each time. Notice here, if you're looking at the boundaries, up by 12, 12, 12. So the same pattern happens. Okay. Now, for our class limits, the data can have values that are equal to both. So in your data set, you could have values 66 and 77, and they'd both go into a class limit. So something that could equal both a lower limit and an upper limit. Okay, so that sounds a bit strange, and especially when you compare it to the boundaries, where we're saying the data values can't equal both the upper and lower boundaries. Okay, so the best way to understand this is to see it in a different display. So let's suppose we got X, meaning our weight in kgs. That same table that I've just drawn can be redrawn like this. So for our classes, notice your X, your weight, can equal or be larger than 6, and it can be equal 17 or be smaller. So notice, for limits, your value could equal the lower limit, or it could equal to the upper limit. If you're looking at class boundaries, we have our weight could equal 5.5 or be bigger, but it is strictly less than 17.5. It can't equal both. If you have a value, it could equal the lower limit, but we won't have anything equaling the upper limit. Any value in your data set that is 17.5 will go into the next class. It can equal the lower limit, but not the upper limit. Anything that equals 29.5 will go into the next class. Okay, so if something lies on a boundary, on an upper boundary, it'll get pushed into the next class. Okay, so it gets pushed into the next class. That's going to be what we use as a default in Stat 130. It is not a universal way to do it, but unless otherwise specified, this is what you can assume for Stat 130. We can use Microsoft Excel to help us construct a frequency distribution. So we're going to use a command that will allow us to tally the data. Okay, so we still have to go, we have to find out our range, we still have to find out the number of classes, the class width, so that we can work out our class intervals. Only once we find the class intervals can we use Excel to do the tallying, to find our frequencies. So our command we're going to use is equals frequency, and then in brackets the two pieces of information we need to supply. First is the data array. So that's your data you have, the set of values you want to tally. And your bins array, those are going to be the upper class limits. Okay, so we're not going to worry about the lower class limits. You're just going to need the upper class limits. Step 1 will be to enter your data. Step 2 will be to find your classes, which is Sturge's rules, what we've done already. Your third step would then be to insert a column for your upper class limits. Notice here on the edge, our rows 11 to 48 have been hidden just so that we can see the first cell in which the data is entered, so that's cell A2, as well as the last cell in which the data is entered, that's A51. That's just done for convenience. Okay, this slide already looks quite busy, but as we go through the steps, I'll explain why. Okay, so our fourth step would just be to select all the cells where you want the frequencies to appear. So you've got your class limits and upper limits. Okay, so next to that, you want to highlight cells E2 till E8. Okay, then next step, we want to type in the command that we're using, which is equals frequency. We're putting it in there. Our data array first. Okay, so our data is starting in cell A2 all the way down to cell A51. Then we do a semicolon to split it, and we want the bins array. So these are the upper limits. So they are in D2 all the way down to D8. Now notice the colors that have been put in. As we've written in the array A2 to A51, so our data, notice it's been colored in blue, and that A2 to A51 in the command has been put in blue, so you can see which data you're referring to. And then cells D2 all the way to D8 have been highlighted in like a pinkish red color, and in your command D2 to D8 has been written in red, so you can see the range that you're referring to. So you close your brackets, and in your step 6 you do not press enter. You must hold down Control and Shift and press enter at the same time after that. So you must have them all together, and you will get your frequencies in all of the cells. Now if you just press enter, you'll only get the frequency of the first class, and you can't use autofill then to drag down the formula. It won't work. So you must follow these 6 steps.